Bismillahirrahmanirrahim. Assalamu alaikum students. Today we are going to start first chapter of class 10th and number wise it is unit number 10 because first 9 units we have discussed in class 9th. The name of the unit is simple harmonic motion and waves. This word might be new to you, simple harmonic, and you have discussed about motion and you might know the word waves as well. So this word simple harmonic is new to you, but it is not new when you will be able to know about this detail of this chapter. You will know that this is not a new word to you, but terminology is new to you. Understanding will not be new. So after completing this unit, what you will be able to do? You will be able to state the conditions necessary for the object to oscillate with simple harmonic motion. Oscillate means vibrate. Then you will be able to explain simple harmonic motion with simple pendulum, ball and bowl example. And the one more is that mass spring system. These three examples are given, that is missing here. And then you will be able to draw force acting on a displaced pendulum. And then you will be able to solve problems, numerical problems, by using this formula of time period. This is time period formula. T is equal to 2 pi L over G under root for simple pendulum. And then you will be able to understand that damping progressively reduces the amplitude of oscillations. And the next is you'll be able to describe motion as illustrated by vibrations in rope, slinky spring, and by experiments with the water waves. Means we are going to discuss the waves by using these different medias, that is waves in the rope, slinky springs, and waves in the water. And then we'll be able to describe the waves are means of energy transfer without transfer of matter. Means to transfer energy, it is not necessary to transfer the matter itself by using waves. Then we will be able to distinguish between mechanical and electromagnetic waves. These are the types of waves. So we'll get to know about these types. And then further types of mechanical waves will also be discussed, that is transverse and longitudinal waves. And we'll get to understand these waves by using slinky and springs. And then we will be able to define these terms: speed, frequency, wavelength, time period, amplitude, crest, trough, cycle or vibration, wavefront, compressions and rarefactions. These all terms belongs to simple harmonic motion and wave motion. Then we will derive this very important formula for the waves. V is equal to F lambda. Here F is the frequency and lambda is the wavelength. And then we will be able to solve some problems which are related to this formula V is equal to F lambda or F is equal to 1 over T. And then we'll be able to describe the properties of the waves such as reflection, refractions, diffraction by using ripple tank. So all these main concepts we are going to get, and then we'll be able to apply them. And how we are going to connect this knowledge with our daily life, we'll be able to explain diffraction of radio waves but not of TV waves. And one important thing which I want to tell you, that this simple harmonic motion is a particular form of vibratory motion. This is what I told you in the start of the lecture, that simple harmonic word may be new to you, but the understanding is very common for you, that simple harmonic motion is a vibratory motion. So we will start from vibratory motion. It says a body is said to be vibrating if it moves back and forth or to and fro about a point. Another term for vibration is oscillation. Special kind of vibratory or oscillatory motion is called simple harmonic motion, which is the main focus of this chapter. So it means that simple harmonic motion is a vibratory motion, but it is of a special type. And why it is called special, I'll tell you by the definition. He says we will discuss important characteristics of simple harmonic motion and system executing simple harmonic motion. And we will also introduce different types of waves that will demonstrate their properties with the help of ripple tank. So before going to start this 10.1 topic's name is simple harmonic motion, but definition is not given at the very start of the topic. So we'll jump to the definition by leaving this page. This was page number 2, and then page number 3, page number 4, 5. So page number 5, the definition of simple harmonic motion is given at page number 5. So first we'll try to understand the definition, and then we'll discuss its examples. So he said at the start, he said simple harmonic motion is a special form of a vibratory motion. So why it is special? He says simple harmonic motion occurs when the net force is directly proportional to the displacement from the mean position and is always directed towards the mean position. You all know that vibratory motion is to and fro motion of an object, or back and forth motion of an object about the mean position. So simple harmonic motion, because it is a special type of vibratory motion, so body will be vibrating about the mean position. So why it is special? Because two things are happening here. The first one is the net force is directly proportional to the displacement from the mean position. He says the force which we applied on the body to keep it vibrating, that force is directly proportional to the displacement. Means if the body is away from the mean position, then more force will be applied. And if the body is near to the mean position, the force will be lesser. And the second condition is that this force is always directed towards the mean position. Direction of the force will be towards the mean position. Whether we are discussing simple pendulum or ball and bowl system or mass spring system. These are the three main examples given in your book. And in other words, definition can be expressed in other words because force and acceleration are linked with each other. In Newton's second law of motion, we have discussed that when a net force is applied on a body, acceleration is produced. So we define simple harmonic motion in terms of acceleration as well. It says in other words, when an object oscillates about a fixed position or mean position such that its acceleration is directly proportional to its displacement. In place of net force, we can write acceleration. In mathematical form, we use this definition. Acceleration is proportional to its displacement from the mean position and is always directed towards the mean position. Second point is same, that it is directed towards the uh, mean position. So this is how we define simple harmonic motion. So two main points of this motion are, the first one is that the net force or acceleration is directly proportional to the displacement of the body from the mean position, and the second one is that acceleration or the force is always directed towards the mean position. Now further discussion of this topic will be done in the next lecture. What you have to do, you have to read out these three examples by yourself. The first one is motion of the mass attached to a spring, and this is on page number 2. And then the second one is ball and bowl system. This is on page number 4. And then on the same page, simple pendulum. These three examples of simple harmonic motion you have to read out by yourself. We'll discuss in the next lecture. And for your paper, according to your paper point of view, you have to learn this definition, both definitions of simple harmonic motion, which we have discussed. Till the next lecture, Allah Hafiz.